Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Faikar bin Rosmani and my metric number is MA19197. Okay, today I will present the video presentation about the Engineering Fluid Mechanic Lab, which is the experiment title is Series and Parallel Pump. Okay, we are from Group 3 and Section 03. So this is our group members. Okay, so firstly, I will present the introduction. Centrifugal pumps are hydraulically driven device that converts fluid energy into a field of centrifugal forces. Their primary task is to increase pressure so that fluids can be transferred. The impeller of centrifugal pumps rotates inside the housing. The impeller is made up of several blades that, preferably in a radial configuration, impart kinetic energy to the fluid being squeezed. The casing has nozzle for the pump fluid suction and discharge. The suction nozzle is along an axis. They aligns with the impeller's axis of rotation, yet the discharge nozzle remains on the plane where the axis crosses despite being parallel to the impeller axis. So, so for the figure beside illustrate the operating principle of a centrifugal pump. Through the exhaustion nozzle that is situated in the center of the impeller, the fluid is immediately injected into the pump. Once it reaches the impeller's edge and empties into the casing, it is then driven radially. The push that the impeller blade's curvature impacts to the current causes it to flow more quickly. In this way, the fluid obtains energy mostly by increasing its average velocity. The amount of fluid inside the casing is correctly lowered because of the gradually increasing amount in the direction of movement. The systems require a low flow rate or head cannot typically be produced by a single pump. By connecting two or more pumps in parallel and series, this issue can be solved. We can increase the heads of which a particular fluid flow rates can be pumped by using series pumps. Additionally, deploying several coupled pumps in a parallel helps boost flow rates while preserving a constant head. This approach system may be a viable option when demand call for an extremely large pump and motor. So, for the objective of our experiment is to demonstrate pump performance curve for a single pump, series pump, and parallel pump. Next, we will consider fluid flow rates and efficiency in parallel and series pump. So, for the theory, pumps are mechanical tool. Pumps are mechanical tools used to move fluid between locations. This hydraulic system transports fluid from low to high pressure and from low to high levels. The pump transforms the fluid's mechanical energy into pressure of hydraulic energy. The hydraulic pump can also be used in applications that need a lot of hydraulic pressure. Lower suction and higher discharge pressure are required for heavy machine. Low pressure on the pump's entrance side causes the liquid to ascend from a predetermined depth, while high pressure on the pump's output side forces the liquid to the desired height. So the type of pumps, there is two type of pump, which is the first one is positive displacement pump. Okay, this pump increase hydraulic pressure while removing fluid from the impeller using mechanical parts such as gears, lobes, rotor, plunges, and pistons. Therefore, a positive displacement pump doesn't generate any pressure. It only creates a seamless flow. Additionally, it might self-prime, obviating the requirement for manual priming. There are various categories used to classify positive displacement pump. The following is classification of positive displacement pumps, which is A. Reciprocating pump, B is rotary pump, and C is pneumatic pump. Okay, the second one is dynamic pump. By raising pressure, a dynamic pump moves fluid via the impeller and diffuser. The impeller increases the fluid's velocity, which the diffuser can convert into pressure energy. To pump the fluid, centrifugal force is employed. There are several different varieties of dynamic pump, which is A is centrifugal pump and B is vertical centrifugal pump. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Nurkalija binti Kamaruddin. I will present about the procedure of the experiment. So firstly, this is the experiment 1, which is single pump operation. What the procedure is, first we have to connect the stopcocks as shown in figure above. Second, we should turn off the valve when the handle is parallel to the pipe and open when the handle is perpendicular to the pipe. Third, do not turn on the pump number 2. Instead of pump number 1 should be turned on using the main switch on the switch box. Next, to ensure continuous water inflow into the reservoir, adjust the volumetric flow with the drain cork. Next, collect the data on measurement value for P suction on the intake side of the pump number 13 and P delivery of the delivery side of the pump number 14. Lastly, repeat the previous measuring procedure and collect the data. Next is the experiment 2 of the series pump operation. Firstly, we have to connect the stopcocks as depicted in this figure. Second, turn on both pumps, which is pump 9 and 10, using the switch box main switch at 11. Third, adjust the volumetric flow with the drain corks to make sure the reservoir receives water continuously. Next, collect the data of the measured value, which is P1 has P suction 1 on the intake side and P delivery 1 on the delivery side, which is 14. Second, P suction 2 on the pump intake side 2, which is 15, and P delivery 2 on pump 2 delivery sides at 16, at point 16. Next, change the volumetric flows and repeat the previous measurement method. Lastly is experiment 3, which is parallel pump operation. In the figure above, we should connect the stopcocks. Second, handle in line with the pipe close valve. Handle perpendicular to pipe, open the valve and turn on both pumps, which is pump 9 and 10, using the switch box main switch. To ensure continuous water inflow into the reservoir, set the volumetric flows with the drain cork, which is number 8. Write down the measured value, which is P suction 1 on the pump intake side and P delivery 1 on the pump delivery side 1, which is at 14. P suction 2 on the pump intake side 2, which is at 15. P delivery 2 on pump 2, which is at 16 delivery side. And P outflow at the outflow number 17. Lastly, change the volumetric flows and repeat the previous measurement method.
Assalamualaikum and hi, my name is Muhammad Faizal Aiman bin Aslin. My ID number is MA19144 and I will be explaining about discussion for lab series of parallel pump. For discussion, there are three questions, question A, question B and question C. So for question A, compares the experiment performance curve to its theoretical curve and describe the discrepancy factor. The theoretical performance curve for a series pump design is comparable to the experimental curve displayed in the previous figure. The head for the series pump is higher than the parallel pump in the experiment performance curve, which is also true for the theoretical curve. As can be seen in the parallel and series pump figures, the flow rate also complies with theoretical curve that indicate parallel pumps have larger flow rates than series pumps. The theoretical curve is 15, where the head is mean to drop as flow rate increases, differs from the experimental curve for the series pump. The experiment curve variability could be due to the surface roughness, internal clearances, and the viscosity of the fluid. For questions B, from the results obtained, state the use of series and parallel pump. The outcome shows that employing a series pump arrangement raises the flow's overall head while keeping the flow rate constant. The total head of the flow is same for parallel pump setup, but the water flow rate is higher. As a result, using a parallel pump will increase flow rate, whereas using a series pump will increase pressure. For question C, explain why the system with series pump configuration would generate higher pressure than the parallel pump configuration. When pumps are arranged in series configuration, the outlet of the one pump is connected to the suction side of the second pump, and each pump is putting energy into the pumping fluid. This results in a higher pressure generation than when pumps are arranged in parallel format. As a result, the head from discharge fluid from the first pump and the discharge fluid from the second pump are added together to get the overall head. Two pumps share the same suction condition and are connected to a shared discharge line. when they are configured as parallel pumps. Because of this, there is just one pressure increase as opposed to two with a series pump. Therefore, the total head for a parallel pump design is equal to the head from pump 1. In summary, a series pump system has a higher head than a parallel pump arrangement. As we know, the head can be delivered consequently, explain why series pump produces more pressure than a parallel pump. So that's all from me. Thank you.
Hi, hello, and good day to everyone. My name is Arvind, son of Tyagarajan, and my metric number is MA19143. Today, I'm going to present about the result part for Lab 4. For that, in Lab 4, we conduct three types of experiment to get the final value. First is for the single pump. In single pump, we measure the volume flow rate and then P suction and P delivery, pressure delivery and pressure suction. After we get it the pressure suction and pressure delivery, we calculate to get the pressure difference for the single pump, then net head in water horsepower. To this pressure change, net head power and water horsepower, we use this formula as mentioned. This formula for the pressure difference, we use the pressure delivery minus pressure suction. So this is the example how I get the value. Then this is the how I use this formula to get the net head. So to get the net value, net head value, I use the pressure difference over density times gravity. So density is, or we all know that 1000 kilogram per meter cube, and the gravity is a 9.81 meter per second square. So after we get the net head, then only we can calculate the water horsepower. To calculate the water horsepower, I use the formula of density times gravity times net head and times Q. So this is the after I substitute all the value, I get it the 0.1489 watt for the 0.000498 flow rate. And then I follow this formula to get all the data to complete the table. Next, we're going to see about the graph of the net head versus volume flow rate. So we can get that when the flow rate is increase, the net rate also increase. Next, for the second part of the experiment, it is a parallel for the parallel pump configuration. So this time we calculate the for value for the parallel pump configuration. So as already mentioned as previously, this condition we already have two pumps. One pump, there is a first pump and second pump. Both pump we have to take the pump suction delivery pressure and the delivery pressure for the both pumps. These are the formulas that I use to get the values. So for the net head, I calculate by using the delivery over, as previously mentioned, I use the same formula. Then I calculate and combine the total net head. We get it this value for the first. And then water horsepower, same like previously I mentioned. So I use this formula and I get it for the water horsepower 1 for the pump 1, water horsepower for pump 2. Then I total the water horsepower, I will get this 0.18087 watt. And then now you guys see about the graph that after I do the calculation, I get it that this is the graph for that. And then final part of the experiment is a series pump configuration. For this series pump and parallel pump, their methods of the tabulate and the formulas are same. So I use the same formula as previously mentioned in the parallel pump configuration. I calculate the net head for the pump 1 and then net head for the pump 2. Then only I calculate the total head net, and then I use the head net value to find the water horsepower. So for the water horsepower 1, I used this formula as previously mentioned, and I got it the 0.1179651. For the horsepower 2, I got it the 0.1393521. After I total the horsepower 1 value and horsepower 2 value, I get it the 0.25731. And this is shows that the graph for the series pump configuration. The graph also show that when the head net is increased, the volume of flow rate also increase as the head net also increase. That's it now from my side. My friend will be continue. Thank you.